Let's take a look at some cases where there's actually multiple cases of the question. So how many words of any number of letters can be formed from cans? So repetition is allowed. And what I mean by multiple cases is here, well, you could have a word with one letter, you could have two letters, three, or four. Now, fortunately, right now, there is no repetition of letters here, so that kind of makes this a little bit easier. Now, if I just have one letter, and if I'm using so we have one letter, there's four choices for it. So it could be four, or we could write that as four, pick one. And then for two letters, well, you got four and then three choices for the second letter, and we could also write that as four, pick two. And then for three, it could be 4 times 3 times 2, or it could be 4, pick 3. And the final one, I'll just write it as the permutation. It's 4, pick 4, because we want all of the possible choices. Now these are all completely separate cases. So we're not going to multiply these cases together, we're going to add them. Now depending on the question, you could actually put this into factorial form, or we can use a calculator to do that. I think we'll just do it in the calculator all at once, and I'll assume that you can do that at this point, and you get 64. So there's 64 different variations of words that we can get if there's no repetition allowed. Let's do one more example of a multiple case. So how many 4-digit positive numbers less than 4,670 can be formed using the digits 1, 3, 4, 5, 8, and 9 if repetitions are not allowed? Alright, so repetitions not allowed, just meaning we can't use like 3 multiple times. Makes your life a little bit easier. And the fact that it has to be less than 4,670 means that 5, 8, and 9 cannot be the first digit. So that leads us into our multiple cases then. If we could have 1 as the first digit, so it could be 1 and then blank, blank, blank for the other 3. And we could also have 3 first, blank, 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 and we could also have 4 first. Now let's deal with 1 and 3 to start, because there's no other restrictions on these ones. So for 1, any other number doesn't matter after that. So we have 1, 2, 3, 4, 5 other options, and then 4 options and 3 options. I'm not going to write this as a permutation right now. We'll just leave it in this form, and this is difficult enough. For the 3 first, same thing. It doesn't really matter what the next 3 numbers are. So again, we've got this 3, 5, 4, 3 situation happening. Now this is going to be a little bit confusing when I go to do my fundamental counting principle, because this one must be 1, but there's actually only one choice there then. And then there's only one choice here when it's 3, and only one choice when it's 4. Now the 4 is a bit trickier, because our second digit does matter as well. For our second digit, it can't be 8 or 9. Okay, so we're only left with 3 choices then. Now once we get past the second digit though, then it can be any of the remaining ones left. So we've already used up 2 digits, so out of the 6 there's 4 left, and then we've got 3 left as well. Now we can use the fundamental counting principle to figure out what the probability or the amount of permutations for each one, and then we're going to add them together, because again, they're separate cases. So using a calculator, I'll just do it all at once, you get 156.